Hey folks, I wasn't able to get the exact same problem as we had started in the lecture, but this is the exact same type of problem. It just this one has HCl instead of man. I think the other one was like KBR or something. I don't remember. Anyways, uh, so I'll start from the beginning on this one. And if you can do this one, you can do the other one, and you can do any of these other problems. So one of the things you need to keep in mind is every problem, you kind of solve it in the same way in general. And that's that you're always going to sort of make a list of what do I have, what do I need, how do I get there, okay? And that's just good problem solving one-on-one. If you're not sure how to solve a problem just by looking at it, you should always do that. Start off. So we have here an aqueous solution. It's 20% by mass of hydrochloric acid, and that's the abbreviation for hydrochloric acid, HCl, the chemical formula, I should say. And this has a density of 1.1 grams per milliliter. That'll be the density of the solution. You don't actually need that in this case, and I'll show you a little bit why. But oftentimes you will get extra pieces of information, and for this class, a lot of these things don't matter. But looking back in more advanced science classes, some of these things are actually important for it, for your assumptions that underpin everything you do to be valid. But for your case, there's usually data in these that is not really going to be used in the problem itself, let's say. So you're trying to figure out the molality of hydrochloric acid in your solution. Let's skip that. All right, so the big thing you gotta remember is you have percent by mass. That means you have a mass of hydrochloric acid that's a percentage of the total solution. So whenever I look at a percent, there's an easy way to deal with percents. I can go ahead and put and assume that I have a total of 100 grams. What does that mean? Well, that means that if I have a 20% by mass solution, I would have 20 grams of HCl. I'd have 100 grams total. And notice, by the way, that if you know both of those numbers, I have 20 grams HCl, 100 grams total, then you also know how much water you have. Remember, this is an aqueous solution. The two things in the solution are HCl and water. And so if HCl is 20 grams, total is 100, that means the amount of water is 80 grams, okay? And that's actually what is right here. I have it written down so that you can see what it looks like. So remember, the percent by mass is always your number of grams of whatever solute you're talking about, divided by 100 grams of your solution, and that would give you a percentage. All right. By the way, the trick here is that if you use 100 grams, this gives you up here, this gives you a nice round number like 20 grams. Because percentages are just parts per 100. Or another way of saying that is percentages are out of 100. Okay, the density isn't really needed for this solution. This would be if you needed it for like a mass volume comparison. So if you had like a percent volume or something like that, you may need the density. Or if you were doing like molarity, you may need the density. But you're not, so you don't really need it in this question. Okay, so what are we trying to figure out? Well, we're trying to figure out molality. And what is molality? It's the small m. It is the moles of your solute over the kilograms of your solvent. Well, your solute is HCl. So we don't know the moles of your solute yet. We, however, do know the mass of your solute. 20 grams. Well, wait. There's something that we know can convert between mass and moles, or vice versa. And that would be the molecular weight. So you look up your periodic table, and you go H, that's a 1, Cl, that's a 35.5, and so the total molecular weight of HCl is 36.5 grams per mole. We know that we have 20 grams of HCl, so all we have to do is just take that number of grams of HCl, we divide it by 36.5 grams of HCl for every 1 mole of HCl, which is our, again, molecular weight or formula weight, depending. And so that would give us, we have 0.548 moles of HCl in this solution that we're looking at. Remember that we have 20 grams of HCl and 80 grams of water, H2O, because that's what would give us 100 grams, which would be our total. Okay, so now we know that we have the moles of HCl. We actually have grams of water here, so we just need to get that into kilograms of water to get our molality. So we're going to go ahead and set it up. Right here we have 0.548, the number we came up with, moles of HCl, our solute. We divide it by 80 grams of H2O. But we don't want grams, we want kilograms. So we go ahead and do the unit conversion, which is 1,000 grams are in a kilogram. By the way, if you don't have these unit conversions down, you really need to practice at them. This is something that should be automatic and just already flow from your tongue, flow out onto the paper. This should not be something you have to sit there and think about. Okay, so once we do the work, so we take this number divided by that and multiply it by 1,000, we'll get 6.85 small m, which is molality, HCl. And that's our answer. And that's actually the entire thing. You see, it actually is fairly easy to complete this problem. The problem itself doesn't take a lot of time. What takes all the time is me explaining each number. And this is what takes most of the time. Is a lot of people typically have difficulties with percentages because they sort of get skimmed over them, I guess. Remember again that a percentage is something out of 100. And so there's a very easy way to deal with percentages. You always should go ahead and just assume you have a total of 100 unless you're given specific numbers to work with. And that makes all of your math and everything else easier in life. Now, I would like to point out that you could use whatever numbers you wanted this ratio. For example, if you said I have 10 grams total, this number would be 2 grams. Those all give you a 20% HCl by mass, because 20% percentages are relative numbers. I wanted to make sure that's clear for everybody. It's something people have difficulties understanding sometimes. Let me know if you didn't understand anything about this, or if you had any issues. You take care. Have a good day.